Happy Friday. Today is Friday, December 4th. What we're going to do today is it is a Friday, which means we are going to do that root word notebook check. So be sure to take a picture of your root word notebook. You should have 40 terms in there by now, okay? Please take a picture of your root word notebook. Make sure I can see all 40 terms and upload that as your assignment. That is going to be a quiz grade, so make sure that you get that in to get your points. Now, we're going to practice balancing equations just a little bit more because this stuff is kind of tricky. So by now, your gizmo should be handed in. So go ahead and you can, if you would like to, you can open up the gizmo, explorelearning.com, and you can follow along and you can do the gizmo this way in which the atoms will pop up. Or you can try to just do it on paper because eventually we're going to try to just do it on paper. And we're going to check some of our gizmo answers to make sure that our answers were correct. All right, so right now I am looking at activity B, which is and then question 4 where it says practice. So we're going to go over some of those answers which you already should have been answering or that you already should have done. So make sure that Google Doc is submitted, and then go ahead and you can pause the video right now. You can open up Gizmo if you want, but definitely open up that Google Doc that's completed right now. And I'm going to put up my ladybug here. All right, so under practice, I'm looking at the combination or synthesis in which 2 or more elements combine to form a compound. Don't worry about the type of reactions right now. We're actually going to do that next week. But what I want you to do is make sure that our equation is balanced. So remember, the whole reason why we're doing this is because of the law of conservation of matter, which means matter can neither be created nor destroyed. So if I have a sodium and 2 oxygen atoms over here, I need to have a sodium and 2 oxygen atoms over here. It all needs to be balanced. Sorry, I should have got this out ahead of time. I have this cool molecule building kit, which helps us visualize what we're dealing with, and I feel like is an easier way rather than just drawing all the time to help us understand what's going on. So we have nitrogen, which is represented as this, and then we have O2. And my O2, remember the subscript tells you how many atoms you have in that bond. So in an O2 bond, I have 2 oxygens. So I have this one, and I have this one. So here are my bonds. They are going to come together to form N2O, which means, and I've already run out of these guys. Here, 1 second. Which means that they are coming together to form N2O, which means 2 nitrogen, 1 oxygen, and, hold on, bear with me. Sorry about that. I ran out of nitrogens. Here we go. Which means that at the end, they are going to form N2 bonded to an O. It's sort of like a giant puzzle piece, which is pretty cool. Sorry guys, I should have had this set up beforehand. All right, so that's what we're trying to make. We have nitrogen and O2 because we find oxygen in nature bonded together to form N2O. But right now we can see our equation is not balanced. I have 1 sodium and 2 oxygens, 2 sodium, 1 oxygen. That doesn't add up, right? We want it to come together so our building blocks will be equal always. This is not the case. So we do something in which we add coefficients. So you can think of it however it helps you. If the model helps you, you can think of it that way. If the gizmo helps you, you can think of it that way. But what I like to do and how we set up these problems right away is I make a line here, I make a line here, I have my reactants, and I have my products. Your reactants and your products have to be equal. So let's set it up. We have, on this side, we have sodium and we have oxygen. We have sodium and oxygen. Remember, we're just making and breaking bonds. We're not making new elements. So if we have sodium and oxygen on this side, we're going to have sodium and oxygen on this side. Now, we count them up. So we have one Na and an O2. Count your atoms. We have one of them. And we have 1, 2, O2. That subscript tells us how many. We have O2. All right, there's our reactant side. Our product side, let's see what we have. We have Na2. That subscript means there's two of them. 1, 2. O without a subscript just means 1. We have 1. Let's look at our problem. We do have a problem because we're not balanced. So let's go through and we try to make it balanced. I am going to try and balance my sodiums first. So over here I only have 1, over here I have 2. Remember guys, we're never adding subscripts. If we add subscripts, we change the molecule. Subscripts means there's a bond. When we change our coefficients, because when you're balancing, you're always going to put your numbers on the front of your molecule. You can't put it in between and you can't put it after. The coefficients change the quantity, changes how much you have. So if I have 1 sodium over here, 2 over here, I have a really easy way to just go put my coefficient 2. What that means is I am adding another sodium to the equation. So this Na means 1. 2 Na means that there's just 2 of those atoms now. They're not bonded together. I just increased the quantity. So 2 Na, I come down here, I turn this into a 2. Now my sodiums are matched up, but my oxygens are not. I need more oxygens over here. Again, I can't just add a subscript. That would change the molecule. That would turn that into N2O2, which is a completely different molecule. I just want to increase the quantity. I do that by adding that coefficient, 2. That is now telling me that I have 2 of the N2O. So, again, I'm not changing the bonds. I'm just, and off the top of my head, I don't know if this is the right structure for it, but I'm just kind of putting it together right now so we can understand those atoms. So this, all I did when I added that 2 is here's one N2O, here's the other N2O. I just increased the quantity. I did not mess around with the bond. I just increased how much is there to make the reaction happen. So that's what that 2 N2O means. So then I multiply it through. I know I have 2 of these, which means altogether, if I have N2, 2 of them, 1, 2, 3, 4. So I now have 4 nitrogens. On this side, O2, because that 2 goes through. All right, so I have 2 oxygens now, but now I have a problem. I have 4 nitrogens, only 2 over here. It's a really easy way to solve that. Instead of putting a 2 here, I just simply put a 4. Again, I didn't do any bonds, I'm just increasing the quantity. Here, I now have 4. So that's your answer to number 1 on your practice problems. Hopefully these models help you out a little bit with like the visual wise. Or if you're still having trouble visualizing it, use your gizmo because it actually pops up those bonds there as well. All right, kiddos, let's try a second one. We're going to go a little bit quicker this time when it comes to balancing. Okay, what is next? We have A2O3. That is one molecule bonded together. We can't mess with those subscripts. Then we have everybody's favorite, H2O, yields, here's our reaction, LaOH3, and there's that subscript. So, set up your T-chart. You have your reactants over here, your reactants react. Your products over here. All right, let's count up our atoms. So, what do we have? We have La, we have O, we have H. We have it on this side, same thing over here. LaOH. Let's count our quantities. 2, that subscript right there is telling us how much. O3, and we also have the O over here, so we have 4 altogether. And we look through, we just have 2 hydrogens. Over here, 1. That 3 on the outside tells us that there's 3 OHs. Again, that's the quantity when you see those parentheses. So we have 3 O's and 3 H's. At this point, if you are lost and you don't understand where I'm getting this information from, you're behind and you need to come see me. Or I'm sorry, not come see me. You guys need to Zoom in on Wednesdays. So during my office hours, so we can work together to figure out how to make this work. Or you can contact me, and then maybe we can Zoom during class when I'm here helping the other guys as well. So if you are confused how to get to this point, you need to contact me. Okay? All right. So let's start to balance. What I do is I always look at the easier one. I feel like LA is going to be the easiest one to balance. I know I need 2 of them over here. Again, we're not messing with the bonds. We're just changing the coefficients. We're adding the quantity. So I put a 2 right here. That is telling me now that I have 2 of these molecules. So I switch. I now have 2 of these. But if I have 2 of the front, I have to have 2 of the back because these are all bonded together. So we multiply these. So we have 6 and we have 6 because that 2 times 3 gives us 6 of these. Now over here, I look and I try to see, okay, I'm going to try to balance my hydrogens. I have 2 hydrogens over here. I have 6 over here. I have 2 up here. How can I get from 2 to 6? The easiest way, multiply by 3, right? So you put your coefficient here, that's telling us that we have 3 water molecules. Now remember, we're not making any bonds, we're increasing the quantity. So we have 3 of those, multiply that through, I now have 6 hydrogens, I have 3 and 3 oxygens, and it just so happens that that balances out nicely. So that is balancing in a nutshell. What I want you guys to do is, on Canvas, there's a code for a Nearpod. I want you to go ahead and go to join.nearpod.com, enter that code in. It's going to take you to a simulation. It's going to help you balance equations a little bit more. I want you to spend at least 20 minutes on that PhET simulation. There's levels 1, 2, and 3. It's like a game. It's pretty fun. I want you to at least spend 20 minutes on that. If you're really good at level 1, try level 2. If you're really good at level 2, try level 3. All right? Just like everything else, if you have any questions, feel free to let me know. Other than that, I'll see you guys Monday. Have a good day. Have a good weekend.